Hook. What if the best evidence for alien civilizations isn't a radio signal from a living society, but the dusty ruins of one that died millions of years ago? According to this groundbreaking research, technological civilizations are separated by vast gulfs of time, not just space. The Drake equation tells us that alien societies likely rise and fall across cosmic timescales, meaning passive technosignatures, artifacts that persist long after their creators vanish, might be our best chance at finding them. Problem: traditional SETI searches for active signals, radio transmissions, laser pulses, or megastructures maintained by living civilizations. But this approach has a fundamental flaw. It assumes we're looking at the right moment in cosmic history when another civilization happens to be broadcasting. Given that technological societies might last only thousands of years while galaxies exist for billions, the odds of temporal overlap are vanishingly small. We need a new strategy that accounts for this temporal mismatch, one that searches for evidence of civilizations that may have vanished eons ago. Explanation: imagine walking through an ancient city like Pompeii. The Romans who built it are long gone, but the structures remain, telling us they existed. Passive technosignatures work the same way on a cosmic scale. This research explores three categories of persistent artifacts across different scales. At the microscopic end, there's dust, the inevitable end product when megastructures collide and grind down over millions of years through collisional cascades. At intermediate scales, there are specular reflections from shiny artifacts in our own solar system, potentially detectable through their unusual light patterns. At the grandest scale, imagine lens flares around X-ray binaries, massive artifacts positioned to harness stellar energy that would create distinctive optical signatures. Even Dyson swarms, those hypothetical shells of solar collectors around stars, leave traces. The key insight is that all megastructures eventually degrade into characteristic dust clouds with unusual spectral signatures that betray their artificial origin. Evidence: the research quantifies survivability timescales for various technosignatures. Reflective artifacts in the solar system could remain detectable for millions of years. Dyson swarm components, subjected to collisional cascades, would create distinctive dust distributions that persist even after the civilization collapses. The spectral signatures of this technological dust differ measurably from natural dust clouds, providing a detection pathway through infrared astronomy surveys already scanning the galaxy. Impact: within 5 years, existing infrared surveys like JWST and upcoming missions will have cataloged millions of stellar systems with unprecedented detail. This research provides specific spectral fingerprints to search for in that data. Astronomers can now reanalyze existing datasets looking for anomalous dust signatures that standard astrophysical processes can't explain. We're not waiting for aliens to call us. We're learning to recognize their ancient ruins in data we've already collected. Conclusion: the universe may be filled not with living civilizations, but with their cosmic archaeological remains. By searching for passive technosignatures in the dusty remnants of ancient megastructures, we're finally accounting for the vast temporal scales that separate technological societies. Subscribe for weekly science breakthroughs.